Students, welcome to the last chapter of trigonometry. Last chapter of trigonometry is inverse trigonometric ratios. Now, let us start with the last chapter, that means inverse trigonometric ratios. So, learning outcomes. After watching this video, student, you will be able to define inverse trigonometric function. You will be able to evaluate principal values of the given inverse trigonometric function. You will be able to solve problems based on principles of inverse trigonometric functions. You will be able to understand the properties of inverse trigonometric functions. You also will be able to solve problems based on properties of inverse trigonometric functions. So after watching the whole series of inverse trigonometric function videos, you will be able to solve the problems based on properties of inverse trigonometric function. So let us start. So in this chapter, what we have to what we are going to learn is first is how to define the inverse trigonometric function. First, we are going to see the definition of inverse trigonometric function. Then after that, we are going to see the state or condition for the inverse trigonometric functions. Whether inverse trigonometric function can be exist or not exist. Then we will be define the principal values of inverse trigonometric functions. That means what is the principal values of inverse trigonometric function, how we can find the principal values of inverse trigonometric function, how we are going to use the principal values of inverse trigonometric function. Then we can also see the domain and range of inverse trigonometric function. Okay, if inverse trigonometric function is given, then what is mean by domain of inverse trigonometric function and what is the range for inverse trigonometric function. Then we can also state the properties of inverse trigonometric function. Okay, we can state different properties of inverse trigonometric function, which are very important properties of inverse trigonometric functions that we are going to use to solve the problems. Then we can simplify expressions involving inverse trigonometric functions. Okay, that means we are going to see the examples based on inverse trigonometric function. So the whole chapter of inverse trigonometric function is based on this 6 part. First is definition of inverse trigonometric function, then condition for the existence of inverse trigonometric function, then what is the principal values of inverse trigonometric function, then what is the domain and range of inverse trigonometric function, and then different properties of inverse trigonometric function, and then application of properties of inverse trigonometric function in solving the different sums. Okay, so let us start with the definition of inverse trigonometric function. So the inverse sine function is the function denoted by sine inverse. Okay, sine raised to minus 1 means sine inverse with domain minus 1 1 and range minus pi by 2 to pi by 2, defined by sine inverse x equal to pi. Okay, that means sine y is equal to x. This is the proper mathematical definition. I know you didn't understood what I mean, right? So let us see this diagram. In this diagram, as you can see, this angle, right? Here angle is given. For this angle, we are finding sine ratio. Sine ratio is opposite upon hypotenuse, right? And when opposite upon hypotenuse is given, then to find angle we have to use sine inverse. Okay, still not clear? Okay, once again, suppose this angle this angle is 30 degree. Okay, so sine 30 degree is equal to 1 upon 2, right? Angle is given, angle is 30 degree. Then we are taking sine ratio of this angle. Sine ratio of 30 degree is opposite upon hypotenuse. That means value is 1 upon 2. Okay. Now inverse. In inverse, this value is given. So from this, see what I am writing. I am writing sine inverse 1 upon 2. Okay. Sine inverse 1 upon 2, this value, and that will be equal to this angle. So that is equal to 30 degree. Okay. Just opposite of this. Till now angle is given and we are interested in finding the value, right? Theta is given, 30 degree is given, and we are finding the sine 30 degree value. Now value is given, okay, and we have to find the angle. For that we are using the concept of inverse. So sine inverse 1 upon 2, that is equal to 30 degree. Clear? Now value is given, opposite upon hypotenuse is given, this part is given, and what we have to find? We have to find the angle, and for that angle will be a sine inverse value. Okay, so if sine theta is equal to x, suppose sine theta is equal to x value, so from this we can say that sine inverse x, that is equal to theta. Okay, sine inverse x is equal to theta. If sine theta is equal to x, then sine inverse x is equal to theta. Clear? This is the concept of inverse trigonometric ratio. See here, y is equal to sine inverse x. That means y is a sine value. Okay, then sine x is what? Angle. So y is equal to sine x, where y is a sine value, x is a angle. Then from this what we are getting? Y corresponding angle is equal to sine inverse x, means here x will be a value and y will be a angle. Okay, if it is y is equal to sine x, that means y is a value and x is a angle. But if it is sine inverse x is equal to y, in that case y is a angle and x is a value. Opposite of this, it depends how it is written. Okay, once again, when it is written y is equal to sine x, right? So if y is equal to sine x is given, in that y is a value and x is a angle. But if it is written as y is equal to sine inverse x, so in that case y is angle and x is a value. Okay, it depends how you are writing the term. If you are writing sine x equal to y, in that case x is angle and y is value. If you are writing sine inverse x is equal to y, in that case x will be a value and y will be a angle. Okay, so depending on how you are writing, we can define x and y. Okay, x and y does not have any fixed value or any fixed notation. X and y are variable, so it depends how you are writing the term. Clear? Then the next concept comes domain and range, right? So sine inverse x is given. So x means value. That value will be a domain, and angle will be a range. Okay, so value will be a domain and angle will be a range. So clear? If sine inverse x is given, in that case x means value is domain, and here angle theta, so theta will be a range. So now see the definition. So the inverse sine function is the function denoted by sine inverse x, right? It is denoted by sine inverse x with domain -1 to 1. Okay, domain -1 to 1, -1. See, maximum value for x when x is 90 degree, right? When theta is 90 degree, then sine 90 degree is 1. Okay, when theta is 180 degree, then it is 0. When theta is 270 degree, then sine 270 degree is -1. So the domain for sine is -1 to 1, and range is -π/2. Here it is -π/2 to π/2. Okay, so -π/2 to π/2, this is the range. On -π/2 value is -1. On π/2 the value is +1. Okay, so domain is value. On the basis of value we are going to define the domain. Then range is angle. On the basis of angle we can define range. Clear? So now definition is clear. Inverse sine function, in the inverse sine function is the function which is denoted by sine inverse x with domain -1 to 1 and range -π/2 to π/2, defined by sine inverse x is equal to y, where sine y is equal to x, right? If sine y is equal to x, then sine inverse x will be a y. Okay, so the inverse sine function is also called arcsine, denoted by arcsine. Okay, so forget about this comes at higher level. So in this level, what you have to understand that if sine x is equal to y, then from the definition of inverse trigonometric function we can say that x is equal to sine inverse y. Okay, this is the definition of inverse trigonometric function. Okay, now comes the principal value of the inverse function. So just like the square root function, y is equal to root x is defined such as y square is equal to x, the function theta is equal to sine inverse x is defined so that sine theta is equal to x, right? This is nothing but the definition of sine inverse x. If sine theta is equal to x, then theta will be a sine inverse x. Okay, so there are multiple values for theta, right? There are multiple values for theta such that sine theta is equal to x, right? If sine theta is equal to x, then we know that sine 0 degree is 0. Sine 180 degree is also 0. Sine 360 degree is also 0. Right? So that means if it is given as sine inverse 0, right? Then we don't know whether it is 0 degree or 180 degree or 360 degree, right? Because sine 0 degree is 0, sine 180 degree is also 0, and sine 360 degree is also 0. So if it is written or if it is given as sine inverse 0, then we don't know which value or which angle will be a right answer, right? It may be a 0 degree, it may be a 180 degree, it may be a 360 degree. Okay, so this is the problem with inverse trigonometric function. It can't give the exact angle, it gives the numbers of angles, right? Like here 0 degree, 180 degree, 360 degree. So thus, see, sine inverse 0 will be 0 degree, pi degree, 2 pi, so on. There may be a n number of angles. So sine inverse 0 is multi-valued. Okay, multi-valued means sine inverse 0 has a many values. Okay, so sine inverse 0 is a multi-valued term. Clear? As sine inverse 0 will give 0 degree, pi degree, 2 pi degree, so on. So that means sine inverse 0 is multivariate term. Multivariate term means it will give many values. So when only one value is desired, the function may be restricted to its principal value. Okay? So when we are interested only one value, we are not interested in n number of values, then what we have to do, we have to restrict the function with its principal value. Okay, we have to restrict this sine inverse 0 with its principal value. And what that means? So the least value of the angle, either positive or negative, for which theta is equal to sine inverse x, is called the principal value. Okay, least value of angle means least value of theta. It may be positive, it may be negative, anything, positive angle or negative angle, but the angle should be a minimum. So least value for the angle, either it may be a positive or it may be a negative, which theta is equal to sine inverse x. Okay, so for theta is equal to sine inverse x, which will be a minimum value of theta, is called the principal value. Principal value concept clear? Okay, principal value means, see, sine 0 degree is 0, sine pi degree is 0, sine 2 pi is also 0. So there are many values for 0. Okay, there are many angles for 0. If it is given simply sine inverse 0, then I can say it may be a 0 degree, it may be a 180 degree, it may be a 360 degree, right? We can't say this sine inverse 0 is simply 0 or pi or 2 pi, because all these are values of 0, right? So in that case, for multi-valued terms, for multi-valued function, what we are going to do? We are going to define the principal value. And what is that principal value? Principal value is the least, means smallest value of angle. Okay, smallest value of angle. It may be positive or it may be negative. That value is called as a principal value. Okay, so class, in this video we had seen the definition of inverse trigonometric function, how to define inverse trigonometric function, then range and domain of an inverse trigonometric function, and then we had seen the principal values of inverse trigonometric function. With this, I am concluding this video. So thank you students.